Alrighty, let's take a look at our next thing that we're going to do here for Systems Algebra 1B. So, first thing we did was we kind of went through these system and solution to a system definitions on the first video lesson there. Alright, so remember that a system is just a set of equations, or you can have inequalities. We're not going to get too much into those. And they're combined by that squiggly brace that we call AND. Alright, we've also got that the solution to a system is just an X and a Y, right? It's an ordered pair that makes a sentence true. Right, so we did some of this, right? We checked to see if 611 and 1, -4 are solutions to the system below, right? It's actually the exact same example we did there. Right, we had y equals 3x minus 7 and 2y minus 2x equals 10. Right, so what we can do is we can say, oh, this is the x and this is the y, because that's how they go. Plug in x and y and test it out, right? If it works for both equations, then that is a solution. If it doesn't work for both equations, like this one, then it's not a solution. Right? So that's really all we did. But if we're trying to find solutions to a system, right, just plugging in random points is not a great way to find them, right? There's no way that I could have really known to try 611 unless I went through like hundreds and hundreds of points, right? I could have tried -6, -11. That wouldn't have worked, right? So one way that we can find the solutions a lot more easily is by graphing. So we have a couple steps that we can do to solve systems by graphing. Right? And it is going to use a little, well, actually I guess what I should say is that for distance learning we're going to do a lot of these online. Whenever you run into these on paper again, what you're going to need to do is remember back to how to graph the different types of linear equations you've learned about. Right? I'm talking about slope-intercept form and standard form. Right, so in those cases what you would do is you would start by plotting your y-intercept. You would use rise over run with your slope to find a second point on the graph. And then you would graph the lines, right? You would graph one line and then the other one, right? You can see down here that there's a blue line and then a red line. The solution that we're looking for, the one that solves both equations at the same time, is actually the point where they cross, right? So this point right here. I hopefully set it so that it does like cool little like droplets, like little ripples on a pond when I click. So anyway, so what we've got here is, again, these are the exact same examples that we were doing before. X plus y equals 10 and y equals x minus 5, right? Those come out to be that point right there. That's where the solution is. If we try this one out, it comes out to be 2, -3 down there. So, like I said, we're going to be doing these online in a slightly different way. So attached to, a lot of the assignments and stuff, and you can actually get to this on your own, is going to be a link to a website called Desmos. It's DESMOS.com. And it'll bring you to this page right here. So Desmos is like an online graphing calculator. It's actually really awesome. If you just need like a regular calculator, you can click on one of those. There are activities that you can do if you need to like get a little bit more practice in, because I know that that's what you'd love to do is like, oh yeah, let's do more math. Right? There's like some learning activities and stuff, but what we're going to mostly focus on is this graphing calculator. So start graphing. It'll take a second to load, and then bam, we've got our coordinate plane right here. So I'm going to kind of walk you through a couple of the features of this. Right? So over here, right, is where you enter your equations. Right? So if I just typed in y equals 3x plus 3, right? You can see that like as I typed in things, it just like threw that line right on there. If I change that to +8, it moves the line. If I change it to +1, if I change it to -4, right, it moves the line. I can go back and forth on that. I could turn this into 1 divided by 3x. Right? It can be a little bit tricky to type stuff in, so they've got this little show keypad down here. So if I knew, say I wanted to throw a 1/2 in there, what I could do is I could look down on here and, oops, actually I guess what I would have to do is I would just do 1 divided by 2, right? And then I can move around using these little arrow keys, right? So you can see, if you take a look up in the top left as I'm using these little arrow key things, it spits me into and back out of the fraction, right? Sometimes that can be a little bit important. It's got your x, it's got your y, you can do powers and stuff. But that's kind of the idea, right? You can also type it in just on the keyboard. So what we're going to do here, right, is I am going to be flipping back and forth between tabs, so just a little bit of warning on that. Right, let's try this one out, right? X plus y equals 10 is the first thing that we're going to try plugging in. So x plus y equals 10. What it's going to do is it's going to give me this line that's way over there. Well, I kind of don't want to just have it like way off to the side. So you can do is you can actually click and drag on the window screen. You can also zoom in and out on here. You can adjust a bunch of settings, which, you know, we're not going to mess around with too much. You don't want to go and click that one because that one's going to make everything really weird. Right, but you can adjust things if you really want to dig into it, or you can just click and drag. You can zoom in and out. Right, the scroll also zooms you in and out, but don't scroll out too much because if you might notice, like, oh, the line looks about the same, but you might notice that I'm down out at 100,000 in each direction. So that's not quite where we want to be. We want to be sticking pretty close to, you know, numbers that we work with pretty often. So x plus y equals 10 is the first equation. If I then click right below that, well, bam, brings up another little line where I can insert my next equation. So my next one was y equals x minus 5. So on Desmos, y equals x minus 5. Cool, look at that. So what that did is it just threw that second line on there. It tells me which one's which by the colors. And if you, like, you can make them go back and forth. You can, you know, change the colors. Like, oh, this one's purple now. This one's back to red. I can make it dashed. I can make it dotted, right? But what this is doing is it's showing me that these are where these two lines are going to be. So to find the solution, it's actually pretty easy. You line your mouse up with where the solution should be, and it'll hopefully bring up this little point that tells you what the solution is, right? If you click on it, it'll kind of like set that as a point so you can move your mouse away. Right? You might notice that, like, oh, this is where this intercepts over here. It's at 5, 0. But if I move my mouse away, it disappears. So if you click into it, it'll then like lock that point in. You can click it again to unlock it. Right? So 7.5, 2.5 is supposed to be my solution for these two equations. What would you look at that? 7.5 comma 2.5, right? So if we graphed these on paper, right, we can end up with the same thing that Desmos is going to give us on here. So Desmos is a great tool for what we're doing. All right, let's try this other one out. Y equals 4x minus 11 is the first thing. All right, so to clear these out, you know, you can just like, oh, select it and delete it and whatever else, or you can just hit that little X there, right? It'll get rid of it. If you find that you got rid of both of them, right, it'll still leave you with at least one line there. So it was y equals 4x minus 11. Y equals 4x minus 11. Right? And you might notice that as you start deleting things, it might change the colors on you. So if you like the colors, you just like click and hold on that, and it'll bring up this tiny little menu there. So it's a little bit easier to see. Right, so that's our first line. Our next one is 5x plus 2y equals 4. So click in below, 5x plus 2y equals 4. Cool. So again, it brings us up with these two lines. Right? I can zoom in a little bit if I want to. I can zoom out. Right? What we're really trying to look for is we're trying to get to where these two meet. So on this one, right, it didn't bring up the little dot automatically, but if I click right about where it should be, right, it'll bring up the point that it thinks I'm asking for, which indeed is this point right here. So 2, negative 3 is the answer. And would you look at that? That's what we'd get if we were graphing it on paper as well. Okay. So another couple little things to mention, right? On the set of notes that may or may not be attached to your assignment, if you're in my class, I have attached these to the weekly plan. Right? It has directions for how to do them on a graphing calculator. Right? We're not really worried about that when we're using Desmos, obviously, but they are there if you happen to have a graphing calculator at home like we do at school. There are a couple different ways we write our answers when we're getting these solutions to systems. Right? So you can write them as an ordered pair with an x and a y, right? Just like we were plugging in earlier this week. You can write them as separate values. You could say like, oh, the x is equal to 2 and the y is equal to negative 3. Right? Or one of my favorites is I like to write them like this, right? And telling like, oh, the point is xy, but the x is this first number and the y is this second number. Right? It's just kind of running through it that way. Right? Any of these is fine, right? But they're all different ways to write answers. So I know that this is kind of giving it away by doing these filled in ones, right? But let's try this out, right? Y equals negative x plus 4. Let's try that out. So let's clear out these. This is y equals negative x plus 4. Again, I'm going to click and drag to just move that around a bit. This next one is negative x minus 2. So y equals negative x minus 2. All right, so what I'm trying to do again is I'm trying to look at where they meet. right? Where they cross each other. That's going to be the solution to my system of equations that I have. But I don't see anything. Let's zoom out. Uh-oh. Zoom out more. Oh dear. Right? And I know that it looks like, oh wow, the lines are, oh wow, cool, now they're on top of each other. That's the solution, right? Not quite. If I just kept on scrolling and scrolling and scrolling, these lines are never going to end up meeting, right? So these are what we call parallel lines. So in this case, there is no solution to this system. There isn't a way for me to solve these equations at the same time. Right? So there are no intersection points, so they're parallel lines, and they have the same slope. That's what makes them parallel, is that they have the same slope. So it's okay, you can have systems that don't have any solutions, right? If they have the same slope, and you find that, you know, oh, Mr. Pug, I've been scrolling for hours, right? I'm all the way at 4 million, right? They might not intersect, right? So, you know, that is a situation that you can run into. All right, let's try another one. 8x plus 4y equals 16 is the first equation. 8x plus 4y equals 16. Now the caveat is red and purple, so I'm going to switch that one back. And then our second equation is y equals negative 2x plus 4. Plus 4. All right. Oh gosh, where are we? Did I lose the other line? Oh wow, that's actually weird. What happened here? Oh no, wait a second. Whoa, weird. So you might notice that when I'm clicking into these, right, if I click into the box that has the purple one, it like highlights the purple one. Watch what happens when I click into the box for the red one. Whoa, dude, right? It's not your eyes deceiving you. The red and the purple, if I switch back and forth between them, look to be in the exact same spot, right? So this is another weird situation that you can run into when you're doing these out, right? You may remember that the video lesson for the intro where we were plugging in points, this is the one where I was like, keep on the lookout for this example later on in the week. This is the one where we could find two different solutions that worked. Well, you know, I could find more than just two solutions. I could find any of these points along here are solutions, right? So what we have here is that they are called coincident lines, right? That means that they are literally just one line graphed right on top of the other line. There are infinitely many solutions to this, right? So if you have parallel lines, they don't have any solutions. If you have exactly the same line graphed twice, there are infinitely many solutions, right? So you could have none, you could have infinitely many, or you could just have one, which is what we see a lot of the time. All right, let's take a look at another quick look at a few of these. Right, y equals 2x minus 3. Right. So y equals 2x minus 3, and y equals negative 3x plus 2. Negative 3x plus 2. And so again, what I'm doing is I'm just kind of scrolling around, you know, clicking and dragging to move around. And then I'm clicking where the intersection is, and then it'll kind of bring up this little point that I can hover over and click to kind of lock in. So 1, negative 1 seems to be the solution. Cool. All right, what this is telling me is that if I took these two equations and I plugged in a 1 for x and a negative 1 for y, that would come out as a solution. No other point on the graph, right? If I zoom way out, oh man, we're really going there. Oh gosh, I'm really, really far out. These lines never are going to cross anywhere else. Now I gotta zoom all the way back in, right? Other than that single point, 1, negative 1, right? That is the only place that these two lines are gonna cross. That is the only solution to this system, right? So, you know, out of an infinity of points, that's the only one that will solve this system, which is pretty cool, right? So this is why graphing is a really good way to check for solutions, because, you know, again, if I'm plugging these in one by one, right, get it, one by one, right, it's going to take me actual forever until I might stumble across the right set of numbers, right? Because, you know, could have even not been 1 comma negative 1. It could have been 1.0001 comma negative 1, right? That could have decimals involved there, right? What I might have you do, right, I feel like we're pretty okay. Actually, let's talk about how to do this fraction one on there, just to be sure. So you have y equals negative 1/4 x plus 3. So back on here, I'm going to say y equals negative 1/4, and then so what I'm doing is I did 1/4, and then I'm using the right arrow key to kind of spit myself out of that fraction, so then I'm going to put my x there. All right, so negative 1/4 x plus 3. All right, so that's how we're going to get that fraction in there. For the second one, it's negative 3/2 x minus 2. So y equals negative 3 divided by 2. Use the arrow key to get out of it. Put an x, and then plus 2. Was it minus 2? Plus 2? Minus 2. Cool. All right. And again, you might notice that this negative 4 comma 4, it's exactly what we got if we were doing it by hand. Right? So Desmos kind of does a lot of the heavy lifting for us. All we have to do then is figure out where the 2 points intersect. Right? If you haven't tried any of these on your own yet, I might suggest trying out number 7. Right? You should find that you get negative 3, negative 2 as your answer. Right? After plugging in these two things, 2x plus 3y equals negative 12, and 5x minus 3y equals negative 9. Right? So I'm going to leave it there. I'm going to give those to you to try. It's my gift on this lovely spring day, which hopefully it's not the day where it's actually raining. I don't know what the weather's supposed to be next week yet, but I am out of here for now. Please be sure to check on Google Classroom for additional stuff, especially assignments and resources. Please reach out to your teacher if you have questions. We're here to help. See you next time.